Welcome to this video lecture on the topic depth of penetration. So consider wave equations for a conducting medium. So from the diagram, plane wave entering the conducting medium at a normal incidence. So the incident wave along the x direction is considered, and Ey and Hz are magnetic field, electric field and magnetic field components. So wave transmitted into the conducting medium. So we are going to take the wave equations for a conducting medium, and we are going to discuss about the depth of penetration and the skin effect during the wave propagation in conducting medium. So consider the wave that penetrates the conducting medium, that is the transmitted wave. Let x equal to 0 at the boundary of the conducting medium. So x increases positively into the conducting medium. So here the del represents the square root of 2 by omega mu epsilon. So in this equation Ey is E naught at x equal to 0. So this is the amplitude of the field at the surface of the conducting medium. So now del has, in first equation, has the dimension of distance. So at a distance x equal to del, the amplitude of the field is Ey equal to E naught into e power minus 1, where E naught into 1 by E. So thus the Ey, that is the electric field component, decreases to 1 by E, 36.8% of its initial value, while the wave penetrates to a distance. So hence del is the depth of penetration. So as an example, consider a depth of penetration of a plane electromagnetic wave incident normally on a good conductor such as a copper. So it is related to the angular frequency of omega is 2 pi f. So the depth of penetration becomes del equal to 1 by square root of f into pi mu sigma. So here for copper mu r is 1. So substituting the value of conductivity, we obtain del as 6.6 into 10 power minus 2 divided by square root of f. So here the depth of penetration varies inversely proportional to frequency, square root of frequency. So let's take 60 Hz frequency. So del becomes 8.5 into 10 power minus 3 meters. So the wave penetrates up to 8.5 millimeter, and 1 megahertz it becomes 6.6. So at 30 gigahertz it becomes 3.8. So as the frequency increases, the del becomes decreasing. So the depth of penetration at 60 Hz is the 8.5. So the penetration decreases in inverse proportional to the square root of frequency. So at 10 mm wavelength, the penetration is only of 0.00038 millimeter. So it is very less. So this phenomenon is often called as the skin effect. The high frequency field is damped out as it penetrates the conductor in a shorter distance than a low frequency field. So for electric field decreases to an arbitrary fraction of its original value. So this is the 1% of original value. So this is also called as 1 by E, multiplying 1 by E depth by 4.6, and may be called as the 1% depth of penetration. So phase velocity is given by the ratio of omega by beta. So for the beta equal to 1 by del, the phase velocity in a conductor is given by square root of 2 omega by sigma mu. So since the 1 by E depth is very small, the phase velocity is small. So the velocity is a function of frequency and hence of the wavelength. So dV by lambda is negative, where lambda is the free space wavelength. So the conductors are anomalously dispersive media. The ratio of velocity of a wave in free space to that of the conducting medium is the index of refraction for a conducting medium. So at low frequencies, the index of refraction is very large. To find the wavelength in the conductor, use lambda c equal to omega, f lambda c equal to omega del, or lambda c equal to 2 pi del. So hence the wavelength is 2 pi times the 1 by E. So 1 by E is small for conductors, the wavelength in conductors is small. So electric field is damped to 1% of its initial amplitude. in the metal. So since the penetration is inversely proportional to square root of frequency, the thin conducting sheet can be act as a low pass filter for electromagnetic waves. So these are the comparison table of penetration depth, wavelength, frequency and velocity and refractive index for copper. So at different frequencies, 60 Hz, the wavelength in free space is 5 millimeter, and on 30 GHz it is 10 millimeter. And 1% depth and wavelength are given. Velocity of the conductor, index of refraction also given for various frequencies. These are the assessment question. So define skin depth. So skin depth is defined using the depth of penetration of electromagnetic wave at different frequencies using the term del. And 1% of penetration be defined using the inversely proportional relation between del and frequency, and relation between depth of penetration and frequency also we discussed. So thank you for listening this lecture.